So the purpose for this call, we've got a short agenda here, and I'm going to actually ask if anyone has any additional topics to add. But I figured first we could do a quick introduction of who's here, laying the context of this collaboration, discussing the research plan as it's currently scoped, and any other topics that come up for background information. Then we can collect some topics for discussion. If there are any particular points that are of interest to people on the call, we can collect a couple of topics, and then of course discuss the majority of the call. And then we'd like to have a quick conclusion round and just get some impressions on this format for academic discussions. So ultimately what we're trying to do with this collaboration is bring in kind of the full end-to-end from research and academics, and then how we, ingest and apply those findings from the research into technology and ultimately, building algorithmic policy for the Gitcoin Grants ecosystem, but kind of using this as a model for going from the academic and the research through to applying the research in development, and how we end up with tools that deliver a better systems for all these technologies that we're building. So maybe I'll hand over to Danilo for some context and some background on what's been done so far in this collaboration. And I believe you've got a couple of things to share. So let me cut my screen share here. Just be taking these notes in the background as well. If anyone else to jump in, I'll drop a link in the TE Gitcoin channel.
Yeah. Danilo, is it okay if we do the diagrams before the research plan?
Let me just present the slides very quickly, just to provide a quick context. And I think the diagrams will come in handy. So I'll share my screen here quickly, just to drop some words. Okay, so are you guys all see my screen here? So let me put on the screen here. But as Jeff said, we are creating those modeling Gitcoin sessions, which are public sessions hosted here at the Discord session server. The format that we are taking is to sort of divide into, let's say, two categories of sessions. We have, let's say, the hackers working session, which would involve live coding, would involve actually implementing and handling the technology. And actually, our first session was yesterday. It was a great session, and we already have some records on YouTube, so that people can watch later and so on. And today is going to be the academician session, where we'll have more free discussions, and this is going to be a space where researchers can make suggestions, criticisms, comments. It's a place where let's say, you can discuss the research directions, and also you could see how you could contribute on that in a more academician perspective. And well, the location is here at the Token Engineering, but I think it's important to always say that we have two channels here where we can communicate asynchronously, the TA Gitcoin on the Token Engineering server, or the Token Engineering channel on the Gitcoin Central server. So just to give a very quick historical overview of how this got into existence. Well, this is sort of, let's say, a spin-off of the Block.Science plus Gitcoin research collaboration. Well, I don't know if you know, but I'm a research engineer at Block.Science, and I'm sort of the lead coder. And we've been developing some science work with Gitcoin before, so that we can investigate the collusion phenomenon on when you, let's say, do analysis on the Gitcoin Grants dataset. And we already have some blog posts about it. We have also some GitHub repos that I can show afterwards. But anyway, given that Gitcoin is an open community, we thought, why not also do an open science approach? So one of the things, let's say, one of the things that did kick off that working sessions is the idea that, let's say, we already have a research plan and we wanted to communicate with the public so that the community can, let's say, question it and can see how things are being made and so on. Z is going to give a better overview of that research plan and also how it connects to other research directions. But in a certain way, the task of let's say, the goal of those academic sessions is to sort of, let's say, to go on that HackMD document here. And as you are all going to see, we have a scientific workflow in there. It's loading there. Just wait a minute. So this is public. I can share the link afterwards on the Canyon. But anyway, we have here a scientific workflow where, let's say, we have a objective investigation, which is collusion. And also, of course, there are always complications when you talk about physical social phenomena. And we have a series of definitions that we use to encapsulate our work. And let's say, the goal of a scientific investigation is always to, let's say, you have a hypothesis and you want to disprove it or not. And there is an entire methodology of how you can disprove it. And if it is not disproved, then you could do some applications about it. Else, you could formulate another hypothesis, you could expand the definitions, and so on. And in any case, you always have the next steps, because on a scientific process, you can only disprove, you can never prove, actually. Anyway, yes, this is going to give a high-level overview of that. So I'll share that HackMD document on the Canyon, so if you guys are interested, we can maybe see more data afterwards. So I'll pass the floor here to Z, and yeah. Hey, Z, you are muted.
Yeah, I think you're muted.
Thought it was me.
Oh, no, that was me. Cool. Sorry about that. All right. So this first diagram is just sort of a really like bird's eye view of Gitcoin, like a Gitcoin round. And, you know, obviously, Kevin, if you have any comment where this sort of work fits in. In practice, sponsors donate money to a match fund pool for the round. Then the round starts and users make their own donations to grants individually. And this forms this thing called a contribution graph, which is sort of the center of our work. Now, the contribution graph itself is really just the web of all of the contributions made, but it's used as an input to the QF algorithm, which determines the match fund payouts. And because there's some potential risk of Sybil's and gaming and collusion and various reasons in terms of service, etc., there's a review process that is applied and determines the final contribution graph before the official quadratic funding algorithm execution and the payouts. And so what we're really focused on here is this purple box, both in the sense of what could we observe as this goes, and in the sense of once the round is done, reviewing it for its final use. So unpacking that box, we get to this sort of what I'll call meta research plan, which says, look, we know that the central concept here is the contribution graph, and we did some upfront work to make, think of it like a science bench for this. We did some work to protect the PII data, so we're exposing data sets that don't dox people, and so those data sets we're making available for running the cadCAD model are already sort of anonymized. And then when we generate those contribution graphs, we can do things like compute the quadratic funding, multiple forms of it actually, because of some of the additional policies introduced by Gitcoin, as well as doing some pretty interesting visual inspection, which was largely Danilo's efforts. Now, given that work was done and it was the basis of the write-ups that Danilo shared in his presentation, we're now working on something a bit more, we'll say, actionable. We're trying to support the need for flagging algorithms to catch collusion, and we're doing this through a sequence of taking the graph, identifying subgraphs, looking at some optimization principles, asking how optimal under those principles the particular activities were, looking at histograms or inspecting the distribution, and then asking whether we can come up with a flagging algorithm that would say, well, these things seem to be, surprisingly effective, maybe standing out with how efficient they were in terms of their match funding. And if that's the case, those are the things we might want to inspect normatively, sort of evaluate, hey, was this really organic behavior, or was it potentially attacker or collusion behavior? Understanding that ultimately that attack is a normative interpretation, the data only gives us the idea that maybe this was it so that we could inspect. And we're doing a first version of this, which is outlined in Danillo's HackMD. And I have already started thinking about the second iteration because, as Danillo mentioned, it tends to feed forward. And so there's a sort of simplified version of the problem defined and underway, and there's a slightly more complex version of the same problem kind of being scoped out ahead to keep the project rolling. I think of this as the sort of academic work to define these flows, and I'll give you a quick snapshot of a HackMD that I'm working on, which is sort of a little different from Danillo's. That said, if Block.Science is really working on these two gray boxes, this first one and then the second one, we also highlighted some interesting stuff going on that people might want to hack on if they're interested in playing with these models. And so some good research tasks for beginners would be to just have a look at the quadratic funding algorithm, compute some ratios, look at histograms, and think about how that might fit into a collusion flagging algorithm. And then on the slightly more advanced side, looking at the way that the estimated payouts evolve over time, which leads to, and I think this might actually be wired backwards. This is, well, I guess both of these could go here. We're really talking about the saturation analysis, and this is something that's come up multiple times. Zoe mentioned it in the post-round 8 discussion. Actually, Kevin and I talked about it many months ago when I first started using it, and I was like, hey, what gives? My matching's going down. But ultimately, that's this sort of saturation analysis, which is maybe a little bit more advanced. But we've started to define some metrics that are interesting, and there's some open questions about what the data might tell us about it. And then in particular, maybe the most advanced thing on this chart would be recognizing that these contribution graphs are preferential attachment style, at least from what we've observed, and thus fitting with a Barbashi-style preferential attachment power law model, and asking what that might tell us about fairness, or in particular, it's been referenced in terms of the Matthew effect, and that's a slightly more advanced area, but someone with some experience in network science or algorithmic policymaking might actually want to dig into that. So that's kind of the bird's eye view of the actual science work going on. We're working on these two, and we're sort of throwing out these other areas as, if you really want to get involved, I think these are some cool things to try out, and we can possibly give some advice or guide that work in these sessions. And I guess then the last thing I was going to share is I was working on this outline, which is sort of more formal math definitions, and this is related to solving graph rewiring problems. So if I want to come up with, formal proofs or good heuristics about optimal graph rewirings as part of my collusion analysis, I really want to have some nice, more formal algebraic graph theory definition. So I started putting that together, and it's something that I was planning on escalating to Zoe, because from my conversation with her, some of her interests lie in the more optimal resource allocation sort of policy making domain, which is some of my PhD work. So this is a little bit intense, probably even a little much for this call given the audience, but if people are interested in some of the formalisms on the algebraic graph theory, feel free to let me know, and I'll also share this doc. And so that is what I have. I'm going to pass it back to Danillo, because I believe our main discussion is going to be sort of showing a little bit of what we did in yellow and talking about what we're currently doing in this upper gray box. But also, because it's half discussion, what other people are interested in, and, what we could do to facilitate contributions in some of these other areas is on the table for today. I will cede the floor.
So, my suggestion is to first, let's say, to do a quick round robin, to, let's say, to know who's participating, what are, let's say, what bring it in here, if there are any topics. Depending on, let's say, if we have topics, we can go on to tectonic status, or we can have a more free discussion format. So
Let's start. Go ahead.
Yeah. So just to give an example, so for example, one topic that, let's say, I would like to discuss, if any of you guys have experience with, let's say, network integration problems and so on, is, let's say, we've been studying on a problem of, let's say, of rewiring graphs, in the sense that depending on how you optimize it, you can get into NP-hard problems. So let's say this is a topic that I want, let's say, give to the floor, just to see if anybody's interested in that class of problems.
Maybe we should do the intros, because I think people's backgrounds matter a lot. Like, I would love to talk about random graph rewiring problems, but it would go quickly into pretty heavy math stuff, since my experience with that is like PhD level, and it's pretty math intensive. So if it's not what people's backgrounds are in, I'm not sure if we want to do graph rewiring problems on the call, or at least I can prepare and present in future calls on how to do it, because right now I'm working on it.
Yeah, so let's do the round robin presentation thing. So to introduce myself, I'm Danilo. I'm a research engineer at Block.Science, and well, I'm sort of when you go to the repository on the GitHub, most of the code there probably it was me that wrote. There are some contributions, of course, by Emmanuel, Andrew Clark, and a lot of others, and I hope that we can have a lot of pull requests so that this becomes a public, let's say, becomes truly a community project. But anyway, I think this is it in a sum. I'll pass the ball to the octopus.
Oh, me? My name's Andrew.
Yeah.
I'm a mathematician. I am interested in graph theory and algorithms, so writing proofs and things like that. I don't know very much about the project. I'm just intrigued.
Pass it.
Yeah. Oh, I forgot to say it. You must pass to someone. But nice to meet you.
Okay. Owaki?
Thanks. Hey everyone, my name's Kevin Owaki. I am a co-founder of Gitcoin, and basically Gitcoin's mission is to grow and sustain open source software and to economically empower software engineers. Gitcoin Grants is a pillar of that mission. We've done about $5 million worth of funding to the Ethereum space through Gitcoin Grants. And Gitcoin Grants, as we all know, is based off of Quadratic Voting, which is a model for funding public goods that was written by Vitalik Buterin and Glenn Weil and Zoe Hitzig. And Gitcoin Grants, I think, is what it is because of Quadratic Voting. And I feel a special responsibility to Glenn and Zoe and Vitalik as the biggest Quadratic Voting platform in the world right now, in order to help them solve and make sense of the collusion problem, because that's the Achilles heel of Quadratic Voting. Sybil resistance and collusion resistance is the Achilles heel. And also, just as a pragmatic matter of course, we started off doing $25,000 rounds on Gitcoin Grants, and now we're doing $1 million. And so, we got to stay ahead of the bad guys and bad girls if we're gonna keep growing Gitcoin Grants. And so I'm really excited to be investing in this research and to be working with people way smarter than me. I'll bring the data if you guys can if y'all can bring the analysis. So very happy to be here. I guess I will nominate Emmanuel to go next. I don't know if I want to put someone on the spot who doesn't have video, but Emmanuel, if you're there.
Yeah, that's all right. My name is Emmanuel. I am a research engineer at Block.Science. I've been helping Danilo with Python programming on the Gitcoin context. And I worked on the optimization of the subgraph metric with Danilo. And actually, we hit a roadblock, but we're going to talk about that, right, Danilo? So that's it. I chose J. Joe Bestie.
Hello, I'm Joshua. I'm a cadCAD maintainer and contributor to the alpha release of cadCAD. I'm trying to determine how to leverage the Gitcoin Grants to guide contributions for a scientific computing platform.
I can jump in next. My name is Jeff. I'm helping on the Block.Science side, kind of as a facilitator and communicator, so helping to spin up initiatives like this and communicate the deliverables that come out of these interesting conversations. And I will pass it to Remy.
Yes, hello. I'm happy to be on this call. Pleasure to meet everybody. I am the chair of the LA blockchain of IEEE, also one of the founders of the IEEE Blockchain Initiative, with the intention of educating a lot of devs around the world, educating our members, bringing members together, cross-pollination, establishing platforms. We have been working on ways to fund within the org, which is IEEE, as you know, a nonprofit. We're still working on that to actually not just release papers and publish papers, but to actually build some really, really cool platforms. Separately, I am CTO of a spin-out off a university campus in the UK, where we're working on healthcare and blockchain. More details to come. It's a pleasure to be on this call. Looking forward to collaborating and hopefully participating. And I nominate, who do we have next?
I think Santiago and Angela and Boring are left.
Then I'll take next. I'm Angela. I've co-founded the token engineering community and observed how this space developed over the last 2 years. Now, at the moment, I'm working on a model myself, the Balancer AMM model in cadCAD. We will open source it in a couple of weeks. And now, when I discussed with Danilo how to, about open sessions, open science, what you're planning with this model, with Gitcoin, with this project, I was just thinking, okay, it's really a great opportunity to onboard more people from our community working on their own research goals. And I was excited about what you presented, Michael. So there are, I guess, a range of topics that are interesting for our community. We have this great mix of social sciences, engineering, data science, and I think it's I not only think, I know it's really valuable to bring those different people together. You have to do a little bit of prep work and onboarding to make them able to follow and to make them able to contribute, but then this exact mix of people with various backgrounds is so exciting, and I hope that we can have more people in this group and then dedicated teams who are working on their own topic within the scope of Gitcoin Grants, which I think is really exciting. It has been, I was observing Gitcoin Grants since round 8, myself with TE Academy being one of the grants, and it's really exciting to see this in reality, how this evolves. how teams are using it, building on it, positive, negative effects, and there's so much to find out here in this area.
Personally, and I guess I won't do a big intro, but I'm Zargum, and I'm the founder of Block.Science and one of the originators of cadCAD with Josh Jodesty, who introduced himself earlier. And honestly, part of the reason this is so important to me is because I care a lot about the role of algorithms in policy making and governance of platforms. I've seen them do both wonderful and terrible things as decision-making, as data-driven decision-making in the context of human systems. And the thing about Gitcoin that's so compelling is that this whole space is almost built on it. We're all members of the community. So if we're gonna leverage our skills and learn together on how to better manage a platform, the algorithmic decision-making in that platform in an inclusive and fair way, I can't possibly imagine a better platform for sort of exercising that learning. And putting it into practice than Gitcoin. So I would say just thank you to sort of Kevin and the Gitcoin team for kind of taking on this this idea that the algorithms in the scope of Gitcoin are actually part of the sort of governance surface of that platform as we all experience it. So it's cool to be doing math and social science together and working with algorithms like quadratic funding and these awesome network dynamic processes. So I hope that's as exciting for everybody else as it is for me. And the goal of this is to do this in a way that improves Gitcoin and improves the knowledge and skills at the same time.
Awesome. Did we hear from everybody? Santiago, if you haven't had a chance yet, please feel free to introduce, but if you're not available, that's okay as well. Okay, so maybe we can move into the discussion section. We've got about 25 minutes left in this slot, and if there were any topics that were discussed so far, or as Z mentioned, we can. There are multiple layers to the rabbit hole as to how far we can how far down we can dive. But yeah, if there's any immediate questions from anyone as to the research that's been done so far or next steps in these collaborations, or even asking for more clarification is absolutely okay. There's a lot of different people understanding different aspects of this, so please feel free to ask away.
I guess I could sort of frame the problem / how I think about it a little bit, which maybe will facilitate some discussion. So I'm going to share my screen real quick. All right, and I just wanted to show everyone sort of what I view as the finish line for this. So on the Gitcoin.
Did we lose audio?
Oh, sorry. I should turn on.
Yeah, not hearing you.
Is this better now? Cool. All right. Can you all see my screen? The Gitcoin Grants wiki.
Yep, looks great.
Cool. So basically, I just wanted to sort of show off what I view as the goal line here. So we've collated some information about quadratic funding on the Gitcoin Grants wiki, which is gitcoin.co/wiki/grants. And this excerpt from the quadratic funding paper is what I wanted to show everyone. So basically, this is a quote from the quadratic funding paper. And it basically reads that the central vulnerabilities of liberal radicalism are collusion and fraud. So collusion takes the place when multiple agents act in their mutual interest to the detriment of other participants, and fraud takes place when a single citizen represents herself as many. So
Oh, we may have just lost.
We lost
No, he's back.
sorry about that. I meant to stop sharing my screen and I ended up turning off my call. So basically, I just wanted to kind of like set the framing of what Vitalik and Glenn and Zoe put as the goal line in here. And, one of the challenges is that there isn't really good, solid civil resistance infrastructure in the space to know whether or not people are defrauding by creating multiple identities. And Gitcoin is hard at work integrating different civil resistance mechanisms like Bright ID and Opala, Twitter identities to increase the price of forgery. But in the collusion thing, I guess, Zargam, I don't want to put words in your mouth, but you said to me, well, this is probably a pretty subjective definition, right? Like, anytime we reach saturation in the grants rounds, people are colluding just by contributing because they're acting in their own mutual interest at the detriment of others. And so I think that there's some, I don't know, Zargam, subjective decision-making or policy-making where we're going to have to decide what constitutes collusion and inform the discussion a little bit as we get to the goal line.
Right. Yeah, and I think the key here, and this is an observation I did get the chance to follow up and chat with Zoe about, because you had cited the definition from the paper, and I had asked her about it, and when we did talk about it, she was pretty sort of on page with the idea that, like, the collusion from a purely numerical perspective, where you just say, well, if I take an action and it benefits me and it harms someone else, in the sense of just the marginal effect on the payouts, then that's not really a definition of the that captures the intent, or it captures the sort of the essence of bad behavior, and in the sense that someone's doing something to adversely affect the system in a way that was outside of the goals or the definition of the system. Like, as long as you have a conserved pile of funds, you're always going to have an issue of sort of, okay, well, if I have a fixed amount, I have to allocate it somehow. Whenever I get some of it, someone else doesn't, because it's a fixed pool. So we got to kind of move away from the notion just whether or not I got more and you got less, or my community got more and another community got less of the matching pool, but towards something like thinking of it as a defrauding or a misrepresentation or a dishonest application of funds in order to extract more than what was due, and that's normative. And so the issue is that you could look at the data and say, well, that's collusion because the data said so, and treat the algorithm's output as the definition of collusion. Or you can say that the algorithm provides you a signal or a residual or something which is an input to a human process to determine sort of normatively whether the terms of service were violated. And then at that point, you've remained in the realm of, social systems decision-making. Do we, as the, and in this case, I mean the people responsible for Gitcoin's decisions about sanctions, or whomever's doing that, deciding, okay, well, this did or did not violate the terms of service subjectively, and now we're going to impose this change on the graph and say, well, you don't count, you don't get matching funds or whatnot. And just separating the notion of the algorithm flags something that could be collusion from the algorithm determines that it was collusion. And that once you make that separation, it actually works fine. You're just factoring away what sort of a data scientist does from what a steward or governor or an operator with the responsibility for maintaining health, and there's an interplay between those two things. So I think it's really natural now for us to start to examine as a community what we think collusion feels and looks like, and then informing Gitcoin, the operation, the platform of that, so that you can make decisions, and I mean you in the general sense, you and the team, that the community considers fair and just application of the principles that you've put forth. Cool,
yeah. I'll have to figure out how to update the definition from the paper with what you just said, but I like the direction this is going. And it's important for us to kind of be transparent about the goal line, so we'll have to find a way to do that.
Yeah, but that's really exciting. So I know that this one has been sort of more of a kickoff for future, but maybe a thing that we could do with the group, since we're motivated and we've got tools, etc., is talk about what ways this community would like to participate, because that will tailor the way we use these bi-weekly meetings. So the more you can tell us about how you want to participate in this, the more we can make these sessions valuable to the community, and then in turn valuable to Gitcoin by mobilizing the community to positive effect.
For sure. Z, I got to run. I'll catch up with you on what I missed in the last 15 minutes, but really excited to be working with the community on this unsolved and important problem. I'll talk to you all later. Thanks so much for having me.
Thanks for coming. Cool. I was pretty interested in hearing more about the preferential attachment models and the Matthew effect, which is essentially like a rich get richer effect, or the more attention that is attracted by a grant, the more attention it will then attract, and how we can kind of break these effects that lead to runaway distributions of income and popularity and all that kind of stuff. Do you have any thoughts on that, Z or Danilo or anyone else for that matter?
Well, actually, we did a very initial exploration about that, and actually, if you go to the notebook that we have created on the first blog post, there is having something that could be curious. Of course, it merits for the investigation. I think that if anybody in the community is, let's say, wants to take a direction, could be a good one. I'll share my screen here quickly. So let me see if I can open it. So we have this repository here, the Gitcoin cadCAD module, that everything that we are developing and so on, we are publishing to it. So feel free to fork it and create new branches and so on. And one of the first things that we did, actually, of sheer curiosity, let me try to load that. Actually, I'll try to open a Jupyter Notebook instance here, but I think that we did is to actually plot the Gini coefficient for the Gitcoin data. It's pretty interesting, actually. So let me go here. Taking a while here. Let us see who loads first. Anyway, let's say one of the intents of having also those hackers working session on the day before is exactly also to not only to discuss the directions and the definitions, but also to, let's say, to get the hands dirty. So anything that you feel curiosity about, or anything that you would want to explore but doesn't feel safe to actually get on the code, those hacker sessions can be, let's say, a good place to be to feel comfortable with the model. But anyway, I'll do a very quick presentation about the first notebook that we did produce on the research that we are doing with Gitcoin. The idea of that notebook is to really, let's say, we have a model that creates a network that represents the Gitcoin for each point in time. So it's a dynamic network. And the intent of that is that when we know the Gitcoin network across all points in time, we can also calculate all kinds of metrics. So here, for example, we have the total amount of quadratic match across all grants in USDT. And we could also see how the funding did go, because let's say the quadratic match is different from the quadratic funding. You need to do a normalization. And actually, we have a mathematical specification telling how the quadratic match as implemented works. We can share that afterwards. But when you talk about the meteor felt, about hitcher, one natural question, for example, is: does the quadratic match makes hit people more hitcher or not? And we don't know actually. But of course, with the data in hand and the algorithm in hand, we can do all kind of exploration. So there is a very naive thing that we do, and actually this is, let's say, this is just a simple plot. That here, for example, we did calculate the Gini coefficient across all the contributions on Gitcoin. And this is logarithmic scale, so things explode quickly. But the curious thing is that at the beginning, let's say the Gini coefficient is low. And then after about, let's say, after 25 contributions, things explode and gets stayed about seven contributions. And once has, let's say, sometimes has occurred, it sort of gets in a steady state that, let's say, we have a Gini coefficient of 86%. Which, let's say, when you compare to country-wide metrics, is high, but I mean, you need to compare, for example, with the Kickstarter. You need to compare with similar systems. So there is a lot of research that is possible to do that to, let's say, to have better insights. And I think that we did do that. Maybe this could be an interesting thing for beginners. Is that so? As we have our cadCAD model, we can see how, let's say, here is the Gini coefficient, but instead of being for the contributions, we are seeing the Gini coefficient for the amounts that were matched for each grant. And we have here three possibilities. The blue one, let me just show it. The blue one is the Gini coefficient when you apply the quadratic match algorithm. The green one is how is the Gini coefficient when you remove a certain correction that the Gitcoin team did include on the last 6 months. So after they did apply that correction, the Gini coefficient across grants did get lower. So we can have a zoom here to give a bit more detail. And of course, you are all invited to, let's say, have a look on the repository. It's all open. There was a result that sort of surprised us, because if you look at the headline is the total amount that was contributed without the quadratic match. So let's say it is the match if you have the 1/1 relation. And a curious thing is that when you look at the steady state, the Gini coefficient for, let's say, for a naive implementation without quadratic match is actually lower than with quadratic match. And I mean, this was a bit surprising, and actually this is an open question of why this exactly happens, what are the causal factors behind it. We do have our suspicions that maybe there is a preferential attachment involved, and Zico talk a bit with it. But I mean, probably this is a thing that for beginners could be a very, let's say, you could get a lot of knowledge by exploring that. And well, that's it for it.
I'm gonna scare something that I hope will be helpful. I also sent a link to it in the crossover channel. This is a public textbook on network science. By the author of this textbook is actually the person who developed the preferential attachment model, but it's actually a general. It's a whole textbook in digital form, hyperlinked. And this chapter 5 is about these preferential attachment models. And there's even a section on measuring preferential attachment, which is something I alluded to as a potential analysis that a more advanced user could do. But in general, if you're interested in like network science and computational social science, I would recommend having a look at this textbook, and it provides some introduction in terms of both challenges and opportunities in network science. It contains some good primers on graph theory. This is mostly undergraduate level textbook, but for someone in a mathematical domain. And in any case, we're working with weighted bipartite graphs, and some of the stuff that I was working on, which I'd like to share in the future, does leverage some of the concepts in this book. So, actually, to be honest, we leverage a lot of them. We deal with the basic graph theory. There'll be some adjacency matrices, the algebraic representations for some of the work that we're doing. We have a bipartite graph. We're concerned about things like the preferential attachment model, which appears in here in chapter 5. We're concerned about things like community detection, which relates to some of our subgraph selections for the random rewiring problems. So, in fact, I guess we're also talking about evolving networks in particular, because we're looking at least over the course of a round, we're looking at the way the network changes from, basically time step to time step as maybe these blocks of time, a bunch of people come up and make donations. Is there any sort of internal correlation or correlation with some external factors like the activity on Twitter? And although we might not have the data from the activity on Twitter, truth is we might even be able to get it. That's maybe an advanced topic. But there's a lot of interesting stuff going on here that it kind of fractals out as people get more and more comfortable with the topics. And if this is something that you're interested in, I would recommend working through this book as a point of departure. And there's actually another book on social and economic networks by Matthew Jackson, which I'm not sure that there's a full public version. You can purchase the textbook, or you can get access to at least a few chapters in PDF form. And that book's probably a little more advanced. It would involve sort of network formation games and like a higher degree of overlap between graph theory and game theory if you're interested in it. But I'm kind of laying that out there because do want to get involved. These are some of the core resources that define the tools that one would use in addition to the simulations and the data analysis. I can.
There's another book that if people are interested called Patient Zero. Agent Zero. It's specifically a computational social science book on like agent-based modeling and come from like the economic model. And yeah, I think it's a fairly readable book. I also recommend it.
Cool. Can you share both links? I think that would be great to have it in the channel. I have a question regarding the research direction. When talking about collusion at Gitcoin and other quadratic funding scenarios, I feel that we have pretty easy task in defining the definitely not collusion and certainly collusion. But then there is a huge gray area. And I was wondering if this project can also lead in the opposite direction, not detecting collusion, but rather finding out scenarios or dynamics that take place in the system, then better understand. So being able to point at them, detect them using the signals, and then better understand what's going on in the community to then, as a strategic decision, what direction do we want to take? For example, in crypto, communities really matter, and community work and creating memes and creating excitement is a key, I would say, is a very important aspect. And of course, I would assume this definitely has an impact. And on one hand, we feel it's really good to build communities, to build ecosystems that are supporting a project, that are working on a project, that have skin in the game. Then why, for example, exclude those from Gitcoin grants and reduce matching funds? And there might be a good reason for it, but it might also be that here, if we define this as collusion, just for the sake of here are people collaborating, this might, of course, not be in the overall interest of crypto. So being able to better understand that via using the signals and then take this as an information input to define the direction of Gitcoin grants is for me a very important element. What do you think? So I don't know if you discussed this.
I mean, I have strong opinions that like the normative aspects are part of the system so that they're not really separated. When we talk about collusion, we're not talking about an objective statement that this is or is not collusion, but rather incorporating in the notion of collusion the difference between the observable signals and the underlying phenomena, hence the discussion of normativity earlier in the call. So, I think that's what you're digging at. And I would say that insofar as I'm correct in interpreting your ask, then I would say it very much is in scope because, I guess coming back to this model theory issue, all models are wrong, some are useful, but to what ends are they useful, for whom are they useful, are also important questions. And we have to tie back our models to our lived experiences and our algorithms back to sort of at least the apparent effects they have on the lived experience within the social systems that they're controlling. So, with that in mind, I would say all of that's in scope, but we still have to deal with it scientifically, because otherwise it can devolve. Like, narrative is full of collisions, and there's just this ability to formalize the concepts in order to address them, but not in the sense that this is made absolutely true, but rather that we formalize things so that we can, ask about the strengths and weaknesses of those formalisms. Like, whenever I make a construction, I'm declaring it to be true, but then I'm holding in my mind, but what if it's not true? When is it not true? When would I not want it to be true? Right? So your fuzzy boundary that you talked about at the beginning of your question is actually part of doing good computational science, and social science in particular, is managing the epistemic gap. Always saying, suppose I model the world like this, what is it good for? What is it not good for? What are the boundaries? And so if you want to ask a new question, you got to kind of move the boundary or move the lens. You're like, okay, well, let's take a different construction that can maybe address the question at hand at the cost of losing focus on something else. So part of the reason we have these open academic-y sessions, in addition to the hacker sessions, is the hacker sessions are going to be a little bit more dive down into the weeds, and the academic sessions are a little bit more like, what are we doing? Why are we doing it? Are we questioning our own assumptions? And are we understanding the limits of the tools that we put forward in addition to the strengths of them?
Yeah, one thing that I found interesting about the Angela question is that, let's say, that questions go sort in an opposite direction of, let's say, the approach that we are adopting for the current iteration, in the sense that, let's say, right now, we are looking at the consequences of what if a colluder adopts a strategy that, let's say, optimizes his attack. And of course, there is the problem that we can have false positives, in the sense that you can have non-colluding grants that are very efficient. And Angela questions go is, let's say, sorting the reverse order of, let's say, what makes a grant that is non-colluding successful? And I mean, I think that, for example, I have an answer of what could be a good method for that. And I'm super open to actually, let's say, to hear thoughts about what could lead to that.
Awesome. I just want to remain cognizant of time as well. I know we're at the top of our hour, or I guess our half hour. So we're planning to continue these academic collaboration sessions every 2 weeks. So we have sort of a internal Gitcoin Block.Science research call, and then every other week will be these open community calls. We hope to, bring in some of the academics like Zoe Hitzig, maybe Glenn Whale, some of the people who have worked on the quadratic funding equations before, and also, to jump into kind of the counterfactual analysis of these tools and live data, and having all of the Gitcoin grant data that we can pull into a cadCAD model framework and study and analyze, the Gini coefficients and other relevant network metrics to determine, or to give the Gitcoin team better data to make these choices over how governance policies evolve moving forward, and their interest in pursuing progressive decentralization over those decisions as well. So really interesting opportunities for continued discussion in this area. I did want to leave it open before we close if anyone had any feedback or impressions on this experimental format of these kinds of academic discussions over the topics we've covered today.
Maybe just a pitch that people who are interested should try to pull the models, play with them, and sort of in the future, come to the discussions if possible with some like specific thoughts around the stuff that either what we're doing or what you would like to do, because some aspect of this will be guidance on research being done by others in the community, and some aspect of this will be some presentation and updates on the work that we're doing as a sort of guide. I think the content of the meetings will probably evolve over time as people decide to come and what they're interested in. Like I said, it's been a kickoff. But I know for my part, like I'm going to be working on some mathematics, and I'll be wanting to present some of that and talk through it and like what its implications are or aren't. And I think on the other hand, in the bi-weekly hacker sessions, there'll be quite a bit of work with the cadCAD models and the data itself.
Definitely. I'll also drop the notes from this call, which I'll include links to the cadCAD model repo, the slides, the research plan, the formalizations, some of the diagrams that we went over in this call. I'll drop them in the TE Gitcoin Discord channel just above this voice channel. So please feel free to follow up there. We'll also post notifications about upcoming calls. We'll have another pair programming collab session in 2 weeks, Wednesday. And then this call will be 2 weeks today, again, for more on the academic discussion side of things. So if that's all, we're all good to wrap up. And Boring, I'll reach out to you about the recording and where we get that uploaded, and I'll include that in the notes as well for anyone who is interested in the early part of this call but wasn't able to make it. Thanks very much, everybody. We'll catch you in the next call.
Thank you. Thank you.